Hi students, in this video we will discuss about the answer key for the tutorial problem given. So first see the first problem. Find the output y of t of an LTI system. The LTI system relation is given in terms of a differential equation where we need to find the output when the input is x of t equal to del of t and assume the system is initially at rest. Okay, so here in order to find the output, so the output is nothing but y of t, we need to find it. Okay, so here this y of t is related in terms of differential equation. Okay, so first thing, what in a if whatever it may be, if the differential equation is given, so you need to remove the terms y of t. How we can segregate the terms y of t is, it is simple. The thing you need to apply the properties, that is the differential property. Then we need to find out the transfer function, that is the procedure. If it is given, so you need to find out the transfer function. So the first step is we need to find out the transfer function of the function. So here what actually we need to find is, we need to find the output. So here either you can apply the Laplace transform or you can apply the Fourier transform, because they have given the condition that the system is initially at rest. In this case you can apply either Fourier transform or Laplace transform. If the system is initially having some value, okay, the initial conditions are not 0, in that case you have to choose Laplace transform. Okay, so generally we will prefer Laplace transform. Okay, so when you apply Laplace transform for this, so what you will get is, you will get s square y of s. You have to write applying Laplace transform s square y of s. Okay, so because the initial conditions are 0, I am not going to use the initial conditions. So plus 3 into s y of s plus 2 into y of s, which is equal to x of s. Okay, now here what is given, the input is x of t, we need to find only the output. Okay, if the input is x of t, that is, sorry, if the input is x of t, here the x of t is nothing but your del of t. Okay, so first you need to find out the Fourier, that is the Laplace transform of del of t. Okay, then we have to substitute in this equation and you have to find y of z. Then you need to take a inverse Laplace transform and you have to find out y of t. We know that the Laplace transform of the del of t is 1. So now this equation become x square s of s y of s plus s into y of s plus 2y of s is equal to 1. Now group y of s. So you will get s square plus 3s plus 2, which is equal to 1. Therefore y of s can be written as y of s is equal to 1 by s square plus 3s plus 2. So this is what the y of s we have find out. This is what the output we have find out in frequency domain. But we need to find y of t. So you have to take y of t is equal to, just we need to take inverse Laplace transform of y of s. Okay, so inverse Laplace transform we need to take for 1 by s plus 3 s square plus 3s plus 2. So this can be written as Laplace L inverse of 1 by, so we need to factor it. So here in order to find y of t, we are taking inverse Laplace transform. We have factorized into s plus 1 and s plus 2. Then if you want to find y of t, and if I want to apply any formula, since it is in product, I need to write it in sums. If it is a single term, there is no problem. You can directly apply the inverse Laplace transform. But we are having two product, right? So we need to apply partial fraction. So applying partial, I think you are already familiar with this, all these partial fractions. So applying this partial fraction, what I am getting is y of s is equal to 1 by s plus 1, b is minus 1 by s plus 2. Okay, sorry, b is my correct, right? If s is equal to minus 2, this will become 0, and here you will have minus 2. So minus 2 plus 1 minus 1, so you will have minus 1. When s is equal to minus 1, this becomes 0. Here you will have minus 1 plus 2 1, so a equal to 1. So by applying, now you apply inverse Laplace transform. Applying inverse Laplace transform, this is nothing but e power minus t, that is 1 e power at, right? The formula e power at equal, if Laplace transform is 1 by s plus a, right? So here what you need to do is, here we need to write it as its Laplace transform. Sorry, here it is e power minus at. The e power minus at Laplace transform is 1 by s plus a. So here it is, you have written right correctly, e power minus t, so minus e power minus 2t. Normally you will write every terms in terms of unit impulse, unit function, not impulse, unit step function. So e power minus t u of t minus e power minus 2t into u of t. So this is what the output of the given LTI system. So this is the output we have obtained by applying Laplace transform. The same thing we can do it using Fourier transform. Instead of s, what you will have is you will get j ohm. That's it. So it's the remaining process and all same. The next problem is, they have given differential equation. You need to find the impulse response h of t. The same procedure. Here they have not mentioned any initial condition. They have not mentioned initial condition. The initial conditions is 0. So s ys plus 10 ys is equal to x of s. Combining y of s, you will get s plus 10 is equal to x of s. So h of s is equal to y of s divided by x of s, which is equal to 1 by s plus 10. You need to find h of t. H of t is obtained by taking inverse Laplace transform of h of s, which is equal to L inverse of 1 by s plus 10. So you know this formula is e power minus at formula. So e power minus 10 into u of t. So this is what the procedure to find out the Laplace transform, that is the impulse response of the system h of t. So next problem is h of s is equal to 2 by s square plus 5s plus 6. We need to find out the differential equation, what it is. Here we are having this answer. We need to find out this one. So here the same, we are going to do it in the reverse step. So we know that h of s is equal to y of s by x of s. Okay, so which is equal to 2 by s square plus 5s plus 6. Okay, now we need to actually how we got this, we grouped y of s and we bring it to the denominator, right? Similarly we bring back to the numerator this one. So y of s into s square plus 5s plus 6, which is equal to, take this to the numerator, into x of x. Now multiply with y of s, so you will get x squared y of s plus 5s y of s plus 6 y of s, which is equal to 2x of s. Okay, now here if you want to write down the differential equation, we need to take inverse Laplace transform. So this is, if you have s squared y of s, it is nothing but we are going to differentiate the signal twice, plus 5 into d by, if you are having s alone, you are going to differentiate 1 plus 6 y of t, which is equal to 2x of t. So inverse x of x is x of t, y of s inverse Laplace transform is y of t. So it is very simple. Just we have done in the reverse step to obtain the differential equation. Now consider this problem. They have given one differential equation. Here they have given the initial conditions. Similarly, you need to find y of t when the input x of t is e power minus t u of t. So here what we need to do is, first apply, we have to apply Laplace transform. Here you have to choose only Laplace transform because we need to apply the initial conditions. Okay, so here applying Laplace transform, what you will get is a square y of s. So for this d square yt, we are going to use the initial condition s y of 0 minus y dash of 0. So this is the initial condition, we have to use it. Then similarly here you have to apply for this 4 into s y of s minus y of 0 plus 4 y of s, which is equal to, here they have given x of t, so we will write directly x of s. Then after finding this x of s, we will apply here. Okay, so first find out x of s here. x of t is equal to what? E power minus t into u of t. Therefore x of x is equal to 1 by s plus 1. Yes, taking Laplace transform. Now apply all these values. So here s square of x square y of s. So y of 0 is 0, so this term you won't have any answer. Y dash of 0 is 1. So here you will have minus 1 plus 4 into yes y of s. Y of 0 is 0, so you will get 4 y of s y of s into 4 y of s, which is equal to x of s is 1 by s plus 1. Now we need to simplify this. Take y of s coefficient. So y of s coefficient is s square, so plus 4s plus 4. Okay, so remaining term what you are having is minus 1, which is equal to 1 by s plus 1. Now y of s is into s square plus 4s plus 4. You have to bring 1 this side, so 1 by s plus 1 plus 1. Now simplify this and write. You have to find out y of s. So what you will have is y of s into s square plus 4s plus 4, which is equal to, so take LCM, so you will get s plus 1. So here s plus 1, here you will have s plus 1 plus 1, so it is s plus 2 by s plus 1. Okay, so here what you will get is, so here y of s is equal to s plus 2 divided by s plus 1 into s square plus 4s plus 4. Okay, so here you have to get s plus, you will get s plus 2 s plus 1. So this can be written as s plus 2 into s plus 2. So this will get cancelled, so your y of s is equal to 1 by s plus 1 into s plus 2. Okay, so now you need to find y of t. How will you find y of t? By taking inverse Laplace transform. So if you want to take inverse Laplace transform, first you have to apply partial fractions. So here you have to apply partial fraction a by s plus 1 by b plus s plus 2. So similarly you know how to apply, so apply it and find out. So you will get a value as 1 by s plus 1 minus 1 by s plus 2. So when you take inverse Laplace transform for this, so y of t equal to e power minus t u of t minus e power minus 2t into u of t. Okay, so this is what the resultant. Next, this is the next problem. So the same differential equation given, x of t is given, initial conditions are given, so you need to find the output y of t. Okay, so we will I will explain how to find y of t. So this is what the second problem. So applying the initial fifth problem, this one. So applying the initial conditions. So and these are the initial condition. Applying the initial conditions, I am getting this answer. So I am going to group y of x and remaining term like this. So here this is what the form I will get it. Now what you need to do is you just simplify, and what you need to check is you have to check whether y of s what you are getting is 1 by 6 s plus 4 plus 1 by 2 into s plus 3, so minus 1 by 2 into s plus 2 plus 1 by 6 into s plus 1 plus 1 by s plus 1. Okay, so this is what the thing you will get it. So you check with your answer. So the thing is, I have already explained all 5 problems, so you need to solve this and you need to find y of t here. So you know how to find y of t, taking inverse Laplace transform. Okay, you just try this one, and if you feel any difficulty, let me know. So here consider an RLC circuit. So in this what you need to give is, we need to find the response, that is we need to find the response when the input is given. So here what you need to find is, you need to find the current flowing through the circuit, because it is in series, the current flowing through the circuit is same. Okay, so here we know that by Kirchhoff voltage law, the applied voltage is equal to the voltage across the each component, right? So here the applied voltage is x of t, which is equal to the voltage across VR plus voltage across VL plus voltage across VC. Okay, now here I am going to to represent the voltage equation for all these things. So x of t equal to, here the voltage equation is R into I of t plus L into di of t by dt plus 1 by c integral I of t dt. So this is what the voltage equation for corresponding component. Okay, so next apply Laplace transform for this. So you will get x of s, which is equal to r, here r r I of s plus L, here it is differentiation, so I of s into I of s. So here there is no initial conditions are given, so this is enough. Then 1 by c into integral, if we have integral you have to write I of s by s, so which is equal to x of s. Okay. Now here what is input is given, input x of t is equal to impulse del of t, therefore x of s is equal to, what is x of s here, for before that you need to first combine that is we need to first combine all I of s. So here we know that the Laplace transform of x del impulse is 1. So 1 is equal to I of s into r plus L into s plus 1 by c s. Okay. So here I of s into, so you have to simplify it and you have to write it. Okay. So here applying these things, our resistance values R is 3, L is 1 and C is 1 by 2, so I am getting 2 by S and taking LCM and simplifying this, here you will get S, denominator you will get S square plus 3S plus 2, which is equal to, I am writing in partial fraction A by S plus 2 plus B by S plus 1, taking inverse Laplace transform I of t is equal to, so first you need to find for what is the value of A and B. So here A value is minus 2 by s plus 2 plus b value is 2 by s plus 1. So your I of t is, by applying inverse Laplace transform, minus 2 e power minus t into u of t plus t into e power minus t into u of t. So like that we can apply these Laplace transform in a circuit analysis and find out the required component. Hope you have understand the how to solve the differential equations and how to find out the terms like transfer function, impulse response and the output. So that's what's very simple. Solve all this problem, don't copy it, try it by yourself. Thank you.